Hello everyone, welcome to Fantastic Dataset and Where to Find Them. I am Hasnain Ahmed. I'm going to talk about SLICE-3D. What is SLICE-3D? SLICE-3D is a large and realistic dataset designed to support AI-based cancer detection. It contains over 400K crafted images of skin layer extracted from 3D total body photography. This is important because 3D TBP use regular DSLR camera to capture full body image that contain lower resolution, more realistic image similar to what someone might get from a smartphone photos. The dataset include image more than 1K patient across 7 dermatologist clinics from 3 continents, help improve diversity and reduce bias. SLICE-3D is available in ISIC archive and researchers can freely use it for building and testing more and more efficient algorithm. Let's talk about data and scope of SLICE-3D dataset. Dataset contain more than 400K distinct lesion images extract from 3D TBP scan. Each image is unique title and standardized to 15 by 15 millimeter view. Data was collected over 1K patients across 7 dermatology institutes on 3 continents, including USA, EU, and Australia. The dataset is lower resolution, more likely a smartphone, making them suitable for AI models. The dataset contains metadata such as age, sex, size, and diagnosis. There is two version of dataset. One is CC by NC license, that means for research and non-commercial only. Another one is CC by even more flexible, even profit. Dataset is used for ISIC 2024 challenge. How was SLICE-3D dataset created? The SLICE-3D dataset was built using a system called Vectra WB360, a specialized image ring made of 92 DSLR camera arrays around the patient to capture the entire body in high resolution from all angles. There's a scan called 3D total body photography or TBP. Over 1,000 patients were photographed this way across 7 clinical centers worldwide. From each body scan, lesions were either mutually identified by expert or automated tools. Then using the ISIC expert tools. There is two types of label as a strong label if it is confirmed by pathologist label and otherwise it's called weak label. Now talk about why SLICE-3D is unique. SLICE-3D is out for either a scan laser dataset in several important ways. First, it captures all visible lesions on the body, not just once a doctor thought they're suspicious. This helps reduce selected bias, which is major issue in traditional dataset. Secondly, the image quality is much more realistic. SLICE-3D are not dermoscopy, but instead look more photo take with a smartphone, make the dataset more real world application like general practice. Another key feature is that multiple lessons from the same patient are included. This allows for intra-patient comparison, with many cases how doctor use the ugly dark sign, spotted the one more and look different from the other. Lastly, each image comes from base metadata like size, shape, location of the body, and light contains. SLICE-3D is the first large-scale dataset of the kind of built from 3D TBP, make it visible a step toward AI system. How SLICE-3D can be used? SLICE-3D enable a worldwide range of practical application in dermoscopy and AI research. First, it can be used to train AI models that detect skin cancer from lower resolution images that makes it ideal for teledermatology in rural area where patient may not have easy access to a specialist. Since it's include multiple lesions per patient, SLICE-3D support algorithm that looks for relative difference like ugly duckling sign where one more looks different from the rest. The dataset is also being used for training ISIC challenge, helping researchers benchmark and improve AI system. Overall, SLICE-3D dataset begin us closer to building real-world dermatology tools that are more fair, robust, and accessible. The SLICE-3D dataset is not just an academical resource. It has real clinical relevance. In primary care settings, doctor often see patients with skin constraints, but they might not have access to dermatologists. SLICE-3D enable the development of AI tool that can triangle those cases using regular image, even from a smartphone. This is especially helpful in teledermatology where remote assessment are made based on photo submitted by patient. Because the dataset include all lesions on patient, not just the suspicious one. It also support the using the ugly duckling sign, a clinical method where the one out is flicked. Importantly, SLICE-3D help create decision support system tools that assist but not replace clinics. It's about giving doctor better tools, especially in the place where resources are limited. For reproduction, I use SIFT algorithm. SIFT is the computer vision used to detect key points in the image, compute descriptor, and match feature between the image. In the left side, we can see that original image. That means that image came from the data set, and the right side is the output of SIFT algorithm. Here the key point is 20 and descriptor shape is 128. Let's talk about future work and conclusion. Future work. While SLICE-3D is major step forward, there is still room for future improvement. First limitation is skin tone metadata, which is important for building AI that works fairly across population. Secondly, temporal tracking. And finally, new patient group and global diversity. Conclusion. It contains over 400K realistic skin lesion images. Secondly, it enables practical inclusive AI dermatology because anyone can use it by using a smartphone. And lastly, freely available, which is important for future development.